Okay, the next chapter is Datum. It's also the fourth chapter of solid modeling basic. In this chapter, I will show you how to create datum axis, datum plane, datum CSYS, and also LCS with various methods. Now let's get started. So first one is datum axis. In mechanical design, we often need to create datum axis, which will make our work more easily. In ZW3D, there are 7 ways to create it: by geometry, by face center, by 2 points, by points and direction, by intersected faces, by angular bisector, and also on curve. Okay, you can quickly go through this page, and later I will show you directly in the software. And the next is datum plane. ZW3D also provides 7 ways to create it: by geometry, by offset plane, by angle to a face, by 3 points, on curve, by view plane, and also dynamic way. Okay, you can quickly go through the page as well. Okay, and the next is a datum coordinate system. There are also 7 ways to create it: by geometry, by 3 points, by 3 faces, by an origin and 2 directions, by plane, point, and direction, by view plane, and by dynamic way. Okay, the last page is about the LCS. Okay, in this page, I'd like to introduce you something about LCS. Before the function introduction, I would like to share a little bit about WCS and LCS. So WCS is full named World Coordinate System, which is the default coordinate system with fixed origin and orientation. So sometimes it may not be able to meet the complex scenarios. So this is where we can create LCS, which is full named Local Coordinate System. And in some other software, it may be called UCS or something like that. Okay, so in the LCS, we can set the origin and orientation as required. Okay, and we have 3 methods to create LCS. The first one is by datum coordinate system, and the second is by datum plane, and the last one is a dynamic way to create LCS. You can make it by origin and XYZ directions. Okay, and please note that after the LCS is created, the origin XYZ direction of the system will follow the LCS. But when the part is inserted into the assembly, the default positioning point still the origin of the WCS. Okay. Now let's move over to ZW3D to show you more details. Okay, first, let me show you how to create datum axis. You can activate the command in the datum panel. You can see datum axis, and also you can just activate in the right menu datum axis. It's the same result. Okay, and here you can see ZW3D offers 7 ways to create datum axis. The first one is by geometry. So you can select 1 or 2 geometries. Then ZW3D will offer you the best way to create datum axis. For example, if you select the top face of this shape, then you can see it will create a datum axis which is perpendicular to this surface. Okay, and if you click on one more geometry, which is the point, okay, and then you can see it will create a datum axis which is perpendicular to the surface and start at the point. Okay, and you can flap the direction. Okay, And also you can customize the attribute, like change the color, style, and also the width. Okay, something like that. Okay, and the second way is about center axis, which means you can create a datum axis based on a cylinder face, like this. And also the face can be conical. Like here we select this conical face. Then we can create a datum axis like this. Okay. And the third way is by 2-point. This is very easy to understand, right? We just select the start point and the end point. Then we got the datum axis. And the next command is by point and the direction. For example, we can define this one as origin, and then we define the direction, like here. Okay, then we can get a datum axis by like this. Okay, and the next command is by intersected surfaces, which means if you select two faces, then the datum axis will locate it at the intersected area. Okay, and the next one is by angular bisector, which means you just need to define two directions. Then the datum axis will be created in the middle. Okay. And the next method is on curve. Okay, so first we need to define a curve. And then we can use the percent or distance to define the start point. Like if we use percent, we can make it 50%. Then you can see the start point will be at the middle point. Okay, if we use distance, like we use 10, then the distance between the end point of the curve and the start point of the axis will be 10. Okay, and also we have different direction types. By default, it will be tangent to the curve, and also we can change it to perpendicular, like this. Okay, and also we can flip the directions and customize the attribute. Okay. Okay, this is the 7 ways to create datum axis. Next, I will show you how to create datum plan and the datum coordinate system. We'll use this case to show you. Okay, for datum plan, we also have 7 ways to create it. The first one is by geometry. You can select 1, 2, 3 entities. Then ZW3D will offer you the best solution based on the entities you select. For example, if we select a point and a face, then the datum will be located at the point, and meanwhile it's parallel to the face you select. Okay, but if we select one more face, then you can see by default the face will be located at the point, and then it's perpendicular to face 1 and face 2. And also you can switch between the different solutions. Like we switch it, then you can see the datum plan will be located at the point, and then it's parallel to face 1 and perpendicular to face 2. Okay, this is the first method. Okay, let's see the second method. The second method is by offset plan. This one is very simple to understand. We just select a plan and we define an offset. then you can see the result will be parallel to the face you select and with a certain distance. Okay. The next one is angle to a face. So you can see the required input is a base face, an axis, and then the angle. Like here we can make it 45. Okay. Now you can see the result. Now let's see the next method. The next one is create datum by 3 points. This one is very easy to understand. We just define the origin and define the x point and then the y point. Then we can create the datum plan. And the next method is on curve, which is similar to datum axis. First, we define a curve, and also we use the same method to define the location. And it also can be perpendicular to the curve or tangent to the curve. Okay. And the next method is create by view plan, which means the new plan will be always parallel to the current view angle. Like here you can see. And if we rotate it a little bit and we create again, then you can see it will always parallel to the current view angle. Okay. And the last method is dynamic creation, which means you only need to define a position and then you can get the plan by the handle. Like you can rotate it as required. Okay. And also you can just type the value here. Okay. Okay, this is all for the datum plan. And for datum coordinate system, actually it's very similar to datum plan. Here I will not show you repetitively. Okay, and the next I will show you how to create LCS. Okay, as I mentioned before, we have 3 methods to create datum axis. The first one is create by datum plan. So first we create a datum plan here. We can add the face center. Now you can see we have created a datum plan. And how to create a LCS based on the datum plan is very simple. We just click on it, right click on it, and active as LCS. Then you can see it will be the LCS. Okay. And the next method is create by datum coordinate system. This one is similar. We first create a datum coordinate system. Like we create it here. Okay, and then we right click on it and active as LCS. Okay, this one will be the new LCS. And the last method is dynamic create. You can use LCS command and then we define a position here, and then we can define the direction of the X, Y, and Z axis. We can rotate it as required, and also we can input a value. Okay, now you can see this one will be the new LCS. Okay,